Good morning, everyone. Today we are doing 2C.1, which is on graphs. 2C.2 is going to be on translations. So let's get started here. The first thing I want to look at is y equals x, and x is to the first power up here. So I'm going to make an xy table, and I usually use -2, -1, 0, 1, and 2. Get an idea of what's going on each side of the y-axis there. Okay, so if I put a -2 in up here, I will get y equals -2, okay, because x is -2. So y is -2. All right, so if I put a -1 in, I get -1, 0, 1, and 2. All right, let's graph that. -2, is that -2? -1 is that -1, 0, 0, 1, 1, 2, 2. All right, put a line through it right here, and here you go. Okay, so if x is to the first power, we get a line. All right, now I put those arrows on there because I could put a 3 over here and a 4 or -5, whatever. Okay, so it goes on and on forever. So our domain for this is going to be from -infinity to infinity. Remember, those are our possible x values, and our range in this case will be -infinity to +infinity. Okay, so if x is to the first power, you get a straight line. Let's come down here and look at this one. So I have a y equals x squared. Again, we're going to make an xy table and graph it and look at the domain and range. So this would be y equals -2 squared. And I am squaring all of the -2, not just the 2 part. So if I write that in expanded form, that would be -2 times a -2, which gives me a 4, +4. All right, if I put a -1 in there, I get a 1, a 0, a 1, and a 2. Let's graph that. So -2, 1, 2, 3, 4, -1, 1, 0, 0, 1, 1, 2, oops, that's supposed to be a 4, 2, 4, 2, 4, right there. Okay. I get this U shape here. This is a parabola. Okay, so if you have an x squared, you will have this U-shaped parabola. Now my domain here, I can put any number, real number I want in for x over here. So it's going to go from -infinity to +infinity. And because I got those arrows on there. And then here, for my range, as I'm scanning from the bottom up, I don't run into it until 0. So 0, and it goes on and on to infinity. And it actually includes 0. If you notice over here, that is actually on my XY table. All right, next one here. F of x equals y cubed. Now remember, f of x is just a fancy way of saying y. So here we have y equals -2 cubed. Okay, so that in expanded form means -2 times -2 times -2. So that gives me a +4 times the -2, which will give me a -8. Okay, so this one's -8. This one will be -1, a 0, a 1, and a +8. Okay, let's plot those points. -2, -8, right there. -1, -1, 0, 0, 1, 1, 2, 8. So this one looks like that. All right. So some people say a chicane, an S shape, whatever. It's cubic. This is a cubic function, and it has that particular shape to it. Domain and range on this. Okay, so domain in this case, because we got these arrows on there, and it is moving over slowly but surely, so it's going to go from negative infinity to positive infinity. And my range, again, it's going to be negative infinity to positive infinity on that. Okay, let's take a look at this one. F of x equals the square root of x. You don't know it right now, but next week we'll talk about it. We cannot have a negative number underneath the radical here. So that is just a rule. So whatever's underneath the radical has to be 0 or larger. So if I put a -4 in there, that would be breaking a rule. I can't have that negative number there. So this does not exist. One reason is when we are taking a square root of something, we're asking, what did we square to get this number? And you know, a lot of people say, oh, we squared 2. Well, if we squared 2, we get a +4. And then they'll say, oh, well, we squared -2. Well, if you square -2, you get a +4. So that's why you cannot take a square root of a negative number. Okay, -1 does not exist. Oh, and also notice that I picked some numbers that would be friendly for taking a square of. 0, I can take a square root of 0, because square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Okay, so let's plot these. Well, do I have a place over here called does not exist? No, I don't. So I cannot plot those two. But I can do 0, 0 right here, and I can do 1, 1 here, and I can do 4, 2, 1, 2, 3, 4, and 2. And this one looks like that. Now, a lot of people are like, whoa, that looks like a shooting star. Okay. And this is a radical. Okay, so typically looks like that. Oh, domain on this. Okay, domain. If I scan this way, it doesn't start until I get to 0. And notice 0 is on my list over here, so I have to include it. I'm going to use a bracket, and it goes all the way up to infinity. Okay, my range, as I'm going this way here, it starts at 0, and it goes to infinity. Oops, that's rounded in there. Okay, so that's our domain and range for that. Okay, f of x equals the absolute value of x. Now remember, absolute value means the distance from 0, and distance is always positive. So if I put a -2 in there, I'd have the absolute value of -2, which is the +2. So this will be 1, 0, 1, 2. All right, let's plot those points. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And we get this V-shaped. Okay, so this is just an absolute value. And it is a V-shaped. Okay, domain on this. Well, I can put in any real number over here and I will get an answer out. So my domain is going to go from -infinity to infinity. My range. Okay, so I scan up this way and it doesn't start until I get to 0. And 0 is on my list, so you need a bracket. And it's going all the way up to infinity because we got those little arrows there. So it'll look like that. All right, we're not going to work with this one a whole lot in our class. Math 111 spends a lot of time on these type of functions, but I want you to see it real quick. Okay, so remember well, we'll talk about that in a minute. Let's put a -2 in there. So I'll get a -1/2. Put a -1 in there, I get -1. Okay, let's put a -1/2 in there. So if I have 1 over a -1/2 like that. All right, so 1 divided by a -1/2. Don't like to divide with fractions. We want to multiply by the reciprocal. So I'm going to say 1 times a -2 over 1, which will give me a -2. Okay, so that one's -2. Put a 0 in there. Well, if I put a 0 in down there, I get undefined, so that does not exist. Remember, we're not allowed to have a 0 in the denominator. This one here will give me a +2, this will give me a +1, and this will give me a 1/2. All right, let's plot these. At -2, it's going to be at -1/2. I'm just eyeballing it. -1, -1. -1/2 is at -2. So right there, 0 does not exist. I can't put that on, okay? 1/2 is at 2, 1, 1, 2 is at 1/2. So what we got going on here is we got a function that looks like this. And looks like this. Notice it gets super, super close to the x-axis and the y-axis right there, but doesn't actually cross it. What we have going on here are some asymptotes. This is a horizontal asymptote, and this is a vertical asymptote. All right, and you'll learn all about that in Math 111. All right, so it is nice to know these shapes, so when you see it, you have an idea of what they look like. And on the next video, we're going to talk about moving these shapes around, and that's transformations. All right.